Last class we discussed what expansion? Thermal expansion. And it happens due to asymmetry in potential energy graph. Then I told you if distance between 2 points in a body is L at temperature T, then at temperature T plus delta T, the whole body will expand. So distance between these 2 points will increase. A will also look ಸ್ವಲ್ಪ bigger. So this distance is how much now? L plus delta L. What is the change in length from here to here? So that delta L is given by the formula alpha L delta T. So more is change in temperature, more is the change in length, more is the starting length, more is the change in length. Matlab, if I start with 1 meter and it expands by 1 centimeter, if I take 2 meter at the start, it will expand by 2 centimeter for same change in temperature. So then delta L by L, we write alpha delta T. Another formula is very useful, and that is original length they will write L naught, final length they will write L. Then what will be delta L? L minus L naught. Alpha is a constant, it is called temperature coefficient of linear expansion. Linear. Because here length is increasing, no length. This is what length? Original length. If I write change in length like this, who is original length? L naught delta T. If I take L naught that side, I will get L equal to L naught 1 plus alpha delta T. So these two formulas are very important. Try to remember. For small changes, in fact solids will expand little only. So for small changes, this delta can be replaced by D, differential. So we can also write this dl by L is equals to alpha dt. But this is for small changes. When the percentage change is less than 10%, we can use this. Okay. Area also will change or not? Area. If length will change, area also will change. So for area, we call this areal expansion. Areal expansion. So similar formulas we can write. Without wasting too much time, let us directly write formula. So imagine initial area was A. Initial area was A at temperature T. After increasing the temperature, area became A plus delta A. Then how will you write delta A? Any guesses? Some constant you have to write. That constant we write beta. L or A. A into delta T. So just like delta L has L, here we write delta A as A. This is beta. This beta is called coefficient of, any guesses? That was coefficient of linear expansion. This is coefficient of areal expansion. Similar to this formula, how will I write here? Tell me. If I write initial area A naught, final area A, how will I write? A equals to A naught 1 plus beta delta T. Same way we can do for volume expansion. If you have a solid, then when I say length will increase, it will increase in all the three directions. So length will increase, breadth will increase, height will increase, so volume will increase. So can we write for volume expansion similar formula? How will we write? Delta V equals to, what constant do you think I will put? After alpha, beta, what comes? Gamma. So we will write gamma original volume delta T. And this formula, how it will be here? Final volume will be equal to original volume 1 plus gamma delta T. What will you call gamma this time? coefficient of volume expansion. Some people also call it coefficient of cubical expansion. Cubical expansion. Definitions and all, please see your board material for alpha, beta, gamma. I can define now for you if you want. Gamma, let me define. So to define gamma, what I will do? I will bring this V down here, delta T down. So what is gamma? It is a change in volume per unit rise in temperature. Quickly somebody say units of alpha, beta, gamma. All of them will have same units. Alpha, beta, gamma. Quickly tell. Meter cube will cancel. So delta T will come in denominator of gamma. So it will be what? Per Kelvin or per degree Celsius. Both we can say. Why? Because change in temperature is same in Celsius as well as Kelvin. But Fahrenheit, how to do? If it was per degree Fahrenheit, then how to convert it into Kelvin? If you look at the formula I taught you last class, TF is equals to or TC equals to? TF is equals to 9 by 5 TC plus 32. Check once. So if I take delta, change in temperature in Fahrenheit will be 9 by 5 change in temperature in Celsius. So 1 degree rise in temperature in Celsius will be how much degree rise in temperature in Fahrenheit scale? 9 by 5. So this is per degree Celsius means what? 1 by degree Celsius. So here 1 is there. So this will be how much? 1 by 9 by 5 degree Fahrenheit. 5 by 9 per degree Fahrenheit. So to convert per degree Celsius to per degree Fahrenheit, what will you do? Multiply with 5 by 9. That you remember. Sometimes they will ask. Just like you connected initial volume with final volume, it's also nice to know how to connect initial density with final density during expansion. So let us talk about density variation. Density variation. Now you know that if you take a given mass of a substance during heating, does mass change? Quickly answer the question. Does the number of atoms in that body change when you heat? When you heat, what you do basically? You give energy, increasing the gap between the atoms. So density variation, how to discuss? Since mass remains constant during heating, it means density into volume should remain constant. That means density and volume should be what? Proportional. Inversely proportional. That means if volume increases 2 times, density will become half times. So if volume increases this many times, density will become 1 by that many times. That means density will be equals to original density divided by 1 plus gamma delta T. This part is clear or not clear? Volume increased by this factor, volume increased by this factor, density will decrease by that factor. Because they are inversely proportional. If I bring volume downstairs, cross multiply. Everybody clear? So this is the exact formula of calculating final density in terms of initial density. And why this change happened in density? Because of change in temperature. Not because somebody is applying mechanical force. That also we have learned in bulk modulus. But this is due to temperature changes. Now students, I will ask few things which I taught you people already before. It is related to maths. So quickly remind me. 1 plus x power n is approximately how much if x is much lesser than 1? 1 plus nx. This is one thing I taught you, very important in this chapter, in this topic, especially of thermal expansion. One more thing I taught you is, if any quantity has some constant a power alpha, b power beta, c power minus gamma, then calculating change in x, how to do normally? Normally, first you have to find initial value of a, initial value of b, initial value of c, then calculate this. That will be initial value of x. That's the proper way. Then see what are the changes in a, b and c. That will be add those changes of a, b and c to the original value of a, b, c. Matlab, if somebody says a increases by 2%, then what will be the final value of a? Old value plus 2% of a. So if they give you changes in a, b, c, you can find final value of a this way. Are you understanding? So once you know final value of a, final value of b, final value of c, substitute here and calculate final value of x. Then calculate final value of x minus initial value of x. That will be what? Change in x. That is the proper way. However, when changes are very small, like 2%, 3%, less than 10%, then I gave you one shortcut formula. What was that? Delta x by x is equals to alpha delta a by a plus beta delta b by b minus gamma delta c by c. So this is very, very useful to know the change in x. Or if they ask percentage change in x, then this value you just multiply with 100. To find change in x, I have to cross multiply x also. Because if somebody says find delta x, you can't say this is the answer. This is answer for what? Delta x by x. So you have to cross multiply x. If they ask change in x. But if they ask fractional change, percentage change, then this itself will be what? Answer. This is fractional change. Multiply with 100, percentage change. So very powerful, but again this is used when percentage changes are small, are less than 10%. Otherwise we have to do this way, guys, which I taught you. So using this maths, I can write this one this way now. Look here. Density equals to initial density, original density, 1 plus gamma delta t power minus 1. I took this one up. Now this is perfect till now. Till now there is no assumptions or approximations. Now we will do approximation. If these changes are small, if these guys are less than 1, which normally happens because gamma is a very small number, you will see later. So, if this is quite small, I can use this approximation. Then the answer will be what? Rho naught 1 minus gamma delta t. Understood how? This n will come here. I use this in gravitation chapter also to derive that approximate formula of g with height. So what, this n will come here, so this plus will become what? Minus 1. Sir, can't we write for density also that delta rho by rho formula which I wrote? We can, see here. Because I know this density will be what? Some constant divided by V. Acha, by the way, here in this, when I write fractional change in x, why this constant did not come? This k did not come. Why do you think it did not come here? Because when you take ratio, k will cancel because k will come here also. X will also have k. Delta x, k will come outside because k is constant. So k here, k here, k here, cancel. So similarly, because this is constant, is density equal to constant into V power minus 1. Use this concept because changes are small. So for small changes, how I can write now? For small changes, delta rho by rho can be written minus delta V by V. This power. I'm not understanding. Remove these two. Only one of them is there. This C is constant. This C is constant like this K. In the ratio, constant will cancel. And what was delta V by V? Minus gamma delta T. So please remember, delta V by V is gamma delta T. Delta rho by rho is minus gamma delta T. Minus the sign just tells you that when volume increases, density decreases. Because here we are assuming mass remains constant. Mass remains constant. By the way, this constant is mass only, no? Density is mass by volume. So this C is actually mass only. Relation between beta and alpha. We will assume that the material is isotropic. Isotropic means what? In this direction, if it has temperature coefficient of linear expansion as alpha, then in this direction is also alpha. Matlab in every direction it expands at the same rate. Most materials are like that, but there are many materials also who are not like that. Some materials when you heat in one direction they expand more. In perpendicular direction they may expand less. So that alpha varies with direction. Then we call the materials anisotropic. So we will assume alpha is constant in all directions. So alpha is same in all directions. Check your notes. I have given dl by L equals to alpha dt. So what will be alpha? 1 by L dl by dt. Beta, how will you write? 1 by area, original area, dA by dt. These are all for small changes. So now you remember this. Now let us take a square. To derive this formula, we will take a square. So if I take a square whose side is L, area is A, what is the relation between them? A is equals to L square. Now use my shortcut. Which shortcut you taught, sir? dA by A is equals to first 2 times dl by L. What was dA by A? Beta delta T. dt you bring here, it's a dt. And what is dl by L? Alpha dt. But these are true for only small changes, remember. Better to write here, for small changes. That means if I cancel dt, what will I get? Beta is actually approximately, because these are true for small changes, not exactly. So what is the relation between beta and alpha? Beta is approximately twice alpha. Relation between gamma and alpha? Gamma and alpha. For this, shall we take a volume of a cube? So what will be volume of a cube? Side cube. So volume, now tell my shortcut. dV by V equals to 3 times dl by L. Shall I prove this once more? If you forgot using differentiation. See, it's easy. dV by dl you tell 3L square. Differentiation of x cube, 3x power 3 minus 1. So this you know already. Cross multiply dV. Sorry, cross multiply dl. What will be dV? 3L square dl. Now divide by V. Who is V? L cube. Oh, understood, sir. L square, L cube will cancel here. L cube, L cube. L cube, cube will cancel. See? Now what was dV by V? Think gamma into dt. And dl by L, alpha dt. dt cancel. So gamma is approximately 3 alpha. So what's the ratio of alpha is to beta is to gamma? 1 is to 2 is to 3. So beta by gamma will be what? 2 by 3. Beta by gamma. See this question number 107. The coefficient of linear expansion of a cubic crystal in one direction is alpha 1 and in other perpendicular other directions it is alpha 2. Matlab if you take a cube like this, in this direction if it is alpha 1, in these two directions it is alpha 2, alpha 2. Now what to do? Now what will be gamma? You cannot say 3 alpha. Some of you may guess maybe it is 2 alpha 2 plus alpha 1, which is correct. But we will derive. So how do we derive this? Quickly see here. Volume, how I can write? Length into breadth into height also. Let's say this part is your length and other two are breadth and height. So now use my our shortcut formula. What will be dV by V? What is the power of L? Power 1 will come here into dl by L plus dB by B plus dH by H. Now all of them are length, remember, these are length, just I have given different symbols. What is dV by dV by V? Gamma dt. This dl by L is in this direction, where alpha is alpha 1, coefficient of linear expansion. So how will you write? Alpha 1 dt. For other two, alpha 2 dt, alpha 2 dt. Dt common, cancel. Take dt common, cancel with dt. So what will you get gamma now? Alpha 1 plus 2 alpha 2. Which option? Okay. This interesting question you think. Suppose I have a metal plate, solid metal plate, solid, and I make a circular hole. Now if I increase temperature, the radius of this hole, put the sign, increases, decreases, remains same. Increases, decreases, remains same. How many of you say remains same? How many say decreases? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Majority. Is it majority? Yeah. So majority says decreases. Minority is also M. So majority says decreases. Minority, how many says increases? You said decreases also, increases also. He is that fellow who will go BJP meeting also, Congress meeting also. Huh? How many say increases? 1, 2, 3, 4, 5, 6, 7. So majority says decreases. Majority. Luckily physics is not politics. Otherwise majority will decide. So the right answer is increases. This is wrong. First let me give you one simple answer. When I taught you linear expansion, what I told, distance between any 2 points will increase. So distance between this point and this point will increase. It has to increase. What your brain thought, it will increase like this. So distance between these two you thought distance between these two will also increase. So you thought this way, see, this way. Why it should increase this way only? It can increase this way also. You thought this will increase this way, this way, this way, this way. So volume will be, hole will become smaller, you thought, which is not the case. When you do the experiment, you will see there will be a So this distance will also increase. This distance will also increase. Understood? Best way to understand this is, suppose you take a square plate, make like this kind of design. Don't make any hole, design you make. Now heat. After some time, how it will look? Like this or not? Now make hole here. This hole will become bigger, no? Simple. So distance between any 2 points in the body increases. This is the idea people use to fit your cart wheels. So they have a wooden disc which they want to use as wheel, but wood if you use in the road, because of friction it will wear and tear. So on the rim we want to put what? Iron ring. So but you don't want to just put it like this, then while moving it may fall down. So we take iron rim which is smaller slightly than the wooden, then we heat it. So when you heat, what happens? It expands, so the hole becomes bigger, and then they will fit it and then they will let it cool. So during that time it will nicely fit. So there will be questions like this in your material. There is a ring like this with a cut here. This size is, let's say, D. This size, let's say, is X. This size is, let's say, R. With increase in temperature, which one will increase? All of them. Because when you increase temperature, what I told, distance between any 2 points increases. So distance between these two will increase, distance between these two will increase, distance between these two will increase. So radius obviously will increase. Will you remember? But now I will teach this. In exam this will come. When you increase temperature, angle will increase or decrease or remain same, they will ask. This angle. So when temperature increases, this angle will increase, decrease, remain same. Remain same. So theta will remain same. Now one way to understand this is what? Angle is arc length by radius. Arc length will increase, radius will increase by same factor, 1 plus alpha delta t. So if numerator denominator increases by same factor, ratio will be same. Question number 152, once read. A cube of coefficient of linear expansion alpha s is floating in a bath containing a liquid of coefficient of volume expansion gamma L. When temperature is raised by delta T, the depth up to which the cube is submerged in the liquid remains same. What should be the relation between alpha S and gamma L? So what they are saying, students, is this. There is a cube whose temperature coefficient of linear expansion is alpha S. It is floating in a bath of liquid, floating they told. And the liquid's coefficient of volume expansion is gamma L. They are asking what should be the relation between these two so that this one remains same even when temperature increases. So as temperature changes, this h should remain constant. Which h? This h. Who is this h? The height of the block which is immersed. Now obviously here we have to first find formula for this h. This is question. We have to find relation between this and this. So now, how to find formula for this h first? Well, it's floating. If something floats, net force is 0. Which are the two forces acting on the block? One is mg, other one is buoyant force. Here surface tension force don't count. Actually the surface of water may be like this or like this, depending on whether it wets the solid or does not wet the solid. if you remember. Water in glass like this, mercury in glass like this. So actually surface tension forces can act here, but nowhere in the question they mentioned surface tension, so we will ignore. So here mg, here buoyant force. What was formula for buoyant force? Mass of liquid displaced into g, weight of liquid displaced, and this is whose mass? Mass of solid. Weight of the solid will have mass of the solid. Weight of the body should be balanced by weight of the liquid displaced. Agree? So this is in equilibrium. G will cancel. Now let's say height of the body is h, and this side's area is A. Why, sir, suddenly you thought of writing area in height? Because now mass I have to write in terms of density. So volume has to come. So mass of solid will be what? Density of solid into volume of solid. What is volume of this solid? Area into capital H. Capital H, remember, because it is volume of solid, whole solid. So area into height. Pi r square h. Like that you can think. Of course, it is not cylinder. But for cuboid also we use same formula. Length into breadth into height. Length into breadth is what here? Area. So volume everybody understood? Okay. What about mass of liquid displaced? How much liquid is displaced? This much liquid is displaced. Whichever part is inside or immersed. Very good word you used. So that will be what? Density of liquid, volume of liquid displaced. Area into small h. Area cancel. So what is small h? Density of solid by density of liquid into capital H. I found formula. Once I know densities and heights. Any mistake I did? Yeah, capital H should be here. Otherwise it is dimensionally wrong. Mangoes are equal to bananas, you are saying. Left side is H, right side will be 1 by H. How it is possible? Now, on the right side, whoever are there, I know how to write them in terms of temperature. Hey, density, I taught you how to write in terms of temperature. Solid's height we know, length. Solid's height is nothing but solid's length. So, now we will bring our shortcut formula because all these changes are obviously small. So, tell me how to write dH by H. D rho of solid by rho of solid. Next, plus dH by H minus d rho of liquid by rho of liquid. Check the formula. D rho by rho was what? D rho by rho is same as dV by V with minus sign. dV by V is what? Gamma dt. So this is what? Minus gamma dt. But please check carefully whose rho it is, solid or liquid. By the way, this will be 0. Why, sir, 0? They wanted height to be constant. So the change in which height? The height immersed. And if you want that to be constant, dH should be 0. So now tell me d rho s by rho s minus gamma whose? Solid into dt. dH by h. This height is whose height? Capital H is whose height? When I wrote capital H here, this is mass of solid. So this is whose height? Solid's height. Height is linear or aerial or volume? Linear. So what? How will you write? Alpha s dt. And what is minus d rho of liquid? Minus, what is d rho by rho? Minus gamma dt. But this is whose? Gamma. Liquid. So minus gamma liquid d. This minus sign you understood? This minus is from here, brother. This minus is this minus. This minus is from d rho by rho. Simplify. Minus gamma s dt. Acha, gamma s is not given. They want alpha s. Well, gamma s is solid. For solid, we can write gamma equals to approximately 3 alpha. So gamma s can be written approximately minus 3 alpha s dt Now dt you can take common and cancel. So minus alpha s plus gamma l. If somebody writes like this, next step they will write like this. What happened to this 2 they will ask. Minus 2b will come this side. Okay. 2 cancel. Yeah. That way you can say. What he told is correct. Divide by 2. Very good. If you divide by 2, 2 cancel 2. Here don't cancel 2. No apple. This apple can you see? Take. How much you got? 0. So if you take no apple and divide by 2, you will get 0. That's how dt went out. Very good. Sit down. So minus 3 alpha s plus alpha s minus 2 alpha s. Bring it this side. So what will be gamma l? 2 alpha. Good or bad? Now look here. Next question. I have a cylinder. Bottom area is let's say A. There is water like this here. Why to make it in the middle? Let us make it here. So this is height of container. This is height of container where there is water or height of the water level inside. Question is, this one has gamma, this one has alpha. So please understand, they are gamma and alpha for different materials. So don't write, sir, gamma equal to 3 alpha. Gamma equal to 3 alpha was for one material when I derived, one solid. So now question is, find relation between gamma and alpha so that H does not change. Does not change with temperature. With temperature. Sir, but it will expand. No. But container will also expand. No. And if they expand in such a way that this area of container becomes like, see, normally what will happen? If container's area doesn't change, then volume of liquid to pakka has to increase. So liquid's volume has to increase means height has to increase. But I can always make a special case where I can make the area increase in such a way that the height will not change. So if this also increases, volumes liquid can increase without increasing height. Because you want this height to be constant, create formula for this height. Well, that height will be volume of liquid inside divided by area. But this is area of container. This is volume of liquid. Sir, you said you will not write. Yeah, but let me write. No, otherwise you will think whose V, whose A I have used. Chalo, my game now. Because these two we know how to write in terms of temperature. I mean, their changes, changes. So what will be dH by H? dV of liquid by V of liquid minus dA of container by area of container. Agree? Minus how it came, sir? Because this is power minus 1. If you take A up, what should be dH? 0. Because H is constant. Since H is constant, write down. What is dV by V? Gamma of liquid into dt. Gamma of liquid, they have given gamma. What is dA by A? Go to area formula. dA by A. Beta dt. Beta was coefficient of areal expansion of container, remember. This is for container. Next step, dt will go. Hariharan, dt will go. So what will be gamma from here now? Take this one, this side, cancel dt. Beta. But they have given. Now tell me for whom you can use that formula. Gamma equal to 3 alpha, beta equal to 2 alpha. That formula we can use for liquid or for solid? Solid. So for whom? For beta or for gamma? Gamma is for liquid, ma. So beta is what? Twice of alpha. That's the relation. Same question, no change. One more we will ask. This height should not change. So the next question is, find relation between gamma and alpha so that this height, which I will call y, remains constant. When I say remains constant, I mean with changes in temperature here. So if y remains constant means what, students? H minus h should be constant. That's it. But now we cannot directly use our formula because this is not into, this is minus. No problem, take d. So dh minus dh will be 0. So dh should be equal to what? dh. They must tell you this small h and this capital H how they are related. If they don't tell their relation, you cannot solve this. So if I put this level in the middle, what will be small h? H by 2, but let me keep it at half of half. So h by 4. So this is given, okay guys? Now what I will do to bring our formula is I will write dh by h. Then this side what I should write? Capital H only, no? Mathematics you cannot. 5, ayyo Rama, 10 equal to 10, suppose somebody says. Then I want to write 10 by 5. 10 by. You can't choose this one. You don't have choice. It's fixed, ma. No choice, brother. You have to put 5. The ratio has to be same. So if you divide by h, you have to divide by h. Now what is dh by h? Capital H is whose h? Container. So for container, we can write alpha of container. I will write C, students. Later we will put alpha into dt. This is dh by, what is capital H? 4 small h. Now this dh by h, we don't know. Don't say alpha of liquid, Gadi. Liquids do not have definite length. That formula we cannot apply for liquid's length. Alpha, gamma equal to 3 alpha, alpha is beta equal to 2 alpha is for whom? For liquid, no, volume changes we can write. Length changes we cannot write. This one let us write equation 1. Well, volume of liquid by area of container will give H. I think this is what I used in the first derivation. So what will be dH by H? D volume of liquid by volume of liquid minus D area of container by area of container. This one I want. So keep it there. Before you put 0, Baba, before they told H is constant. Now they are not saying H is constant. So now you cannot put 0 here. Now this only we are searching for. So what is D volume of liquid by volume of liquid? Gamma of liquid dt. And this is beta of container dt. Beta of container can be written in terms of alpha. 2 alpha of container. So dH by H we found or not, people? Substitute Madi. Tell me what you will get. Alpha container dt is equals to 1 by 4. What is dH by H? Alpha liquid dt minus 2 alpha container dt. Correct? What did I do? dH by H I substituted. Now dt we can cancel. Both sides there are dt. So what will be alpha of container? 4 you cross multiply. So 4 times alpha of container will be gamma of liquid minus 2 times alpha of container. Am I correct? Bring minus 2 alpha this side. So what is the relation this time? 6 alpha of container. Your homework is find relation between gamma and alpha so that that volume of space which I told, that should be constant. Try ಮಾಡಿ. Will you try? Think. So much idea I gave you today. Think and see. Even if you don't get the answer, that thinking will be very, very helpful for me. Now see here, everyone. Relation between measured length and actual length. Relation between measured length and actual length. When you make a scale, you will put marking or you will just bring a rod and say, sir, with this rod I will measure. Whose length you want? Tell me, sir. Marking you do first go. So when you make a scale, you have to put marking. That marking is called graduations. You have to do marking. Correct or not? So let's say you put marking like this. Now, this marking, are you listening? So this marking is done in such a way that this is your correct 1 centimeter. This is your true 1 centimeter. True. What everyone says 1 centimeter, that is 1 centimeter. Correct. Tomorrow some baby may say, I will also make scale from here to here, 1 centimeter he may write. You will accept that one? No. So this 1 centimeter is a true 1 centimeter which is accepted by everyone. So this is true 1 centimeter. Now the temperature at which you did marking, that temperature is called calibration temperature. What temperature? Calibration temperature. The temperature at which you did marking. Let's say you did this in Kashmir. Cold day it was. Okay, so 5 degrees Celsius you did the marking. So at 5 degrees Celsius, this length is the true 1 centimeter. Now you brought this, still it is a scale, so it will have some alpha. So this alpha is alpha of the scale. Now, you brought this scale in Chennai. From flight you came. Now in Chennai, the temperature is 40 degree. 40 degree. Marking was done at 5 degree. Now when you bring this in a hot place, what will happen? It will expand. Too much I am showing, that much it will not expand. For clarity. So your 1 centimeter mark will be here now. Now understanding. So your 1 centimeter will come here. Now let's say you want to measure the length of this duster in Chennai. So you will keep it like this. Measured length. What will be measured length? Almost 1 centimeter. That 1 centimeter mark will be 1 centimeter only, no? The centimeter handwrite, that spelling will not change in Chennai. So you will think it is 1 centimeter if you don't know this topic. But because you are Pankaj sir students, you know this topic. Therefore, you will come to know whatever you measured is, think carefully, is more than the actual or less than the actual. Think carefully. I am asking, whatever you measured, that length is the actual length, or that length is more than actual length, or that length is less than actual length? Less. Because actual length of the duster you should have used at what temperature? 5 degree. That time you would have got actual length and it would have been, see, 1.8, 1.9 or 1.7. So actual is more, measured length is less. So when you use the scale at temperature more than calibration temperature, this is the temperature at which you are using the scale, which is greater than calibration temperature, then that time your measured length will be less than Actual length. Many students know students. If I ask, they will say measured length will be more because they think it expands. So measured length is more. But by measured length, I don't mean this length. I mean how much you see here. That is measured length. How much you see. You see 1 centimeter. But it is not 1 centimeter. It is actually more. So 1 centimeter which was supposed to be actually here. This was your true 1 centimeter. That 1 centimeter expanded by this much. So what will be delta L for that 1 centimeter? Alpha L delta T. What is L? 1 centimeter delta T. So this is how much? Alpha delta T in centimeter. So 1 centimeter, the original 1 centimeter expanded by this much. So what will be this new 1 centimeter? 1 plus this much 1 centimeter, the actual 1 centimeter plus this much, which is how much? Alpha delta T centimeter. This centimeter, no? So if you measure 1 centimeter, you should actually think it is how much? 1 centimeter plus this much. Yes or no? Which can be written 1 plus alpha delta T into centimeter. So if 1 centimeter if you measure and it is this much centimeter, then 2 centimeter if you measure, how much it will be? Actually 2 into this. So if you measure L centimeter, how much actually it should be? L into this much. So the actual length, will be the measured length into 1 plus alpha delta T. So this is the formula between measured length and actual length. Guys, understood? Best way to remember is what? Since actual length is more, multiply with this, then only more you will get. This is more than 1, no? See, you are adding 1 with something, so this is more than 1. So you have to multiply with more than 1 to get more. So that way I used to remember as a student. Acha, who is delta T here? Quickly. T minus Tc. T is the temperature at which you did measurement. Tc is the temperature at which marking was done. And whose length we are measuring? Some duster here. So whatever is the actual length of the duster, that you cannot find from this scale. So this scale will give you measured length, then physics will give you actual length. So don't throw the scale just because you came to higher temperature place. Use physics, use same scale. So this is how physics is very useful. Now based on this we must do one question. We must do. See this beautiful question 150. If they give you actual length and they ask measured length, ulta, cross multiply. So L measured will be L actual 1 plus alpha delta T. Aha, I forgot to tell. This alpha is whose alpha? Duster's alpha or scale's alpha? Scale's alpha. Whose alpha it is? Scale's alpha. Duster did not expand, no baba. Who expanded in this problem? Scale. But sir, you changed, you shouted at us. So 2 plus 2, if I shout, confidence is illa. The moment I say scale, you said, duster. If I say duster, you will say board like that. All of you listen carefully. A steel tape measures the length of a copper rod. So there is a copper rod as 90 centimeter. It is measured by a steel scale. The scale is steel and this marking is showing 90 centimeter. when both are at 10 degrees Celsius, which is also what temperature they told? Calibration temperature. So this is the temperature at which the marking was done. Are you clear? Now since here the measurement was done at calibration temperature itself, in this case what is delta T? 0. Because delta T is what? T minus Tc. You are measuring at 10 degree, calibration is also 10 degree, so 0. Delta T 0 matlab what? L actual will be same as L measured. At what temperature but? This is at what temperature? All this is happening at what temperature? 10 degree Celsius. How much measured length they told? 90. So what will be L actual? 90. This is at what temperature? 10. Now see the beautiful thing. What would the tape read? What would the tape read? Matlab what they want? Measured length. Reading matlab through measurement you have to do reading. What would the tape read when both are at 30 degree? Both are at 30 degree. Interesting, sir. Both are at 30 degree. Alpha for the steel is given. Coefficient of linear expansion 1.2 into 10 power minus 5. I told you this number will be very small. See, this is 0.000 some 10 power minus 5, no. And what is alpha of copper? 1.7. From here at least one thing you came to know something. Copper expands more than steel for same change in temperature and initial length. Now the temperature at which you are doing measurement, is this the calibration temperature? No. So now measured length and actual length will not be same. This is the what length? Actual length or measured length? The length of this rod I am saying. Then what is actual length? Measured length is what this number shows. So what I am not saying this length is actual length, this length is actual length, Baba. But what you are seeing here and saying that length, that is not actual length. Tell me the length of, what is this length? Actual length. But actual length of whose? Copper rod. Correct? Now what you measure here, that they are asking. What is the formula? L measured. L A into or by? By 1 plus alpha of whose? Scale into delta T. Now comes the main question. You answer this correctly, I will be super happy. Is this L actual? This L actual? Yes sir, LA. Huh? Wait, we have to think. Symbol, I may have written symbol same. Is this, Shriya stand up. Is this length? This itself? No. Because this was actual length at 10 degree. And they used at what temperature? 30 degree, not only the scale, even the rod. They told both are at 30 degree. So we have to find this L actual at 30 degree. This is L actual at what? 10 degree. And how to relate initial length with final length for a rod? This final length or initial length? From 10 degree to 30 degree. Final length. How to write final length? I told. Initial length 1 plus alpha of rod into delta T of rod. Yes or no? Guys. Sir, we are here only, sir. No need to shout. Huh? Guys, understood? Now, students, most of the time this is enough. Most of the time they will say actual length of the rod is this much. So just put that number. Here they did not give you actual length at 30 degree. They gave you actual length at 10 degree. And actual length at 30 degree you have to find using linear expansion of the rod itself. Now tell me one thing, after doing all this hard work, if you guys do mistake in calculation, how will you feel? Bad or not? Now the numbers are not good. In this in this chapter, numbers are not very good. The small differences matters here. Because solids expands little only. So we have to be careful. So let's see. So L measured at 30 degree, no? What is the measured length at 30 degree? Is equal to, what was the actual length at 10 degree we found? That was same as measured length because that was calibration temperature. 90 what? Centimeter. Now here what do we have? 1 plus alpha of rod you tell. Rod is copper or steel? Copper. So how much? 1.7 into 10 power minus 5 divided by 1 plus alpha of scale. Who is the scale? Steel. What is the alpha? 1 point. Achha, I think I missed change in temperature, no? What is delta T of rod? Rod, be careful. This is for rod. Well, rod initially was at 10. Now it is at 30. So this is 30 minus 10, which will be what? 20. Correct? What is delta T? This is delta T is for the scale, remember. But it's same in this problem. This is for the scale. How much? 30 minus 10. So this is also 20. Now one thing, let us guesswork we will do first. This number is slightly greater than this number. So this ratio will be slightly greater than 1. If you multiply 90 with slightly greater than 1, what will you get? Slightly greater than 90 but close to 90. Which one? Which option matches that way if you do? So I am going with what option? 90.01. Other two options are no chance. But suppose you say, no sir, we are physics students, we want to do properly. Then see what I will try. 90, 1 plus 1, achha, this one though I told how much it will be. 1.7 into 2 will be what? 3.4 into this 010 will be 34 into 10 power minus 5. So 34 into 10 power minus 5, correct? Then this will go up. 1 plus, what will be this number? 24 into 10 power minus 5. Power minus 1. Now binomial expansion. This minus 1 will come here. Because this number is very small compared to 1. Happily you can use binomial expansion. 1 plus x power n. Now open the bracket. 1 into 1, 1. 1 into this minus 24 into 10 power minus 5. 34 into this 1 plus 34 into 10 power minus 5. These two brother, forget these two brother. Why forget? Small number into small number, very small number. See here, this is 90. This is 1. Now minus 24 plus 34 plus 10. So this is plus 10 into 10 power minus 5. That will be how much? 0.000 10 power minus 4. That will be 90 into 1.0001. 90 into this will be what? 90.009, which is approximately 90.01, because 09 is close to 1. Did you see? So it will never reach this big number. Here 2 to no chance only here 2. Okay. Now see this topic, write down. Effect of temperature on time period of pendulum. Time period of pendulum. The derivation of time period of simple pendulum we will be doing later in the course, the second last chapter. But I think while doing units and measurement, we did derive one formula. So the formula for time period of a simple pendulum is 2 pi root over L by G. Maybe this 2 pi I wrote some constant K. But I hope you remember length of the pendulum was in numerator and G was in denominator. Now if it is a thread, then this effect of temperature you can completely ignore. But in grandfather's clock, they use some metal rod kind of thing. Now for metal rod, the formula is not exactly this. We will see all this in oscillation chapter. But T is still proportional to L power half, where L is the length of this rod, let's say. This part is clear? How L power half, G to is constant, no? Gravity will not change because of temperature. This is clear? So now use our concept. What will be delta T by T? Assuming changes are small. What will be delta T by T? Half delta L by L. So D or delta, doesn't matter, small changes. Here I want to write delta, it looks nice. So this is what? Fractional change in time period. Matlab how much time period changes due to change in length. Now why is length changing? Because of temperature, increase in temperature, or it could be decrease. So what will be delta T by T? Half. What was delta L by L? Alpha. Now we will be facing problem. What was delta L by L in our coefficient of linear expansion formula? Alpha. No, now we are in delta T, but we can't write delta T. Why? Why we can have delta T now? This T is what? Time period. Time taken for one oscillation. This T is temperature. You will get completely confused. That's why in this topic we are going to write temperature as theta. So what is this? Change in temperature. So what will be this? Alpha into delta theta. Now listen carefully. If temperature increases, the rod will become longer slightly. So it will take more time to complete one oscillation because length is in the numerator of time period. Matlab it will lose time. The clock will lose time. What do I mean by lose time? Listen carefully. You are eating your food. I want to measure how much time it took. Now, if I use the length of the pendulum, suppose from here to here to here, it took 1 second, which is the proper 1 second which everybody accepts. Okay, so at temperature T, let's say this length was giving you the correct time. So at that temperature, if I measure time taken for you to complete your food, let's say it came 40 seconds, then 40 seconds is the correct time. But now you are using it at higher temperature. That's why there is a what in temperature? Change in temperature. So if you use in higher temperature, this will become longer. So it will go more slowly. So proper clocks are going like this. Proper clocks. This is going slowly. So if actually she took 40 seconds, but this clock may show 20 seconds. So what happened? 20 seconds you lost during that time of eating food. So this formula is for time lost if temperature increases per second, because you are dividing by time period again. So this is half alpha delta theta is what, guys? Time lost per second, but per second. Every second, how much time you lost. Now think it becomes cold. Winter came. Pendulum will become ಸ್ವಲ್ಪ shorter. Now it will oscillate faster. Now properly she took 40 seconds, but now this is going very fast. 1 second, 2 second, 3 second, 4 second. So it will show 60 seconds. So now what happened? You gained extra 20 seconds. So this is also formula for what? Time lost or time gained. Whether temperature increases or decreases. Lost you should say for when temperature increases. Gain you should say when temperature decreases. So this is for 1 second per second because you are dividing by time period. Now tell me what will be time lost or gained per day. Per day will be what? Half alpha delta theta. This is time lost or gained in 1 second, in 2 seconds, into 2, in 1 day, into 86400. How this number came? Number of seconds in 1 day. You can check. 24 into 60 into 60. See question number. How much I told? 155. There is a clock with a metallic pendulum. At 15 degrees Celsius, it runs faster by 5 seconds each day. So at 15 degrees Celsius, the clock runs faster by how much? 5 seconds per day. Matlab in 1 day, it gains 5 seconds. Sir, how do you know it gains, not loss? Because it is moving faster, which happens when pendulum is shorter, which happens at low temperature. So this temperature must be below the correct temperature. What do you mean by correct temperature? That temperature at which it shows correct time. That they have not given. At which temperature it shows correct time, that they have not given. They are just saying at 15 degrees Celsius, it is running faster by 5 seconds. Matlab it gains 5 seconds. Then what they told? And at 30 degrees Celsius, what they told? It runs slower by how many seconds? 10 seconds each day. They want you to find alpha of the material of the rod used in the pendulum. Alpha. Now what they have given you is the delta T in our formula. What was formula for time lost or time gained? Time lost or gained each day. What was the formula? Delta T modulus. Half alpha delta theta. Why modulus you kept, sir? Sorry, into this is per day or per second? Per day. So per day, how much it was? We have to multiply with 86400. This is number of seconds in 1 day. So this is time lost or gained in 1 second. This is time lost or gained in 1 day. That is given. Now since this is a numerical value, we want this to be modulus, positive value. So here better to write bigger temperature minus smaller temperature. So in first case, how much time we gain? 5 seconds. Faster means we gain, no? So 5 seconds. So this is 5. So half alpha delta theta is change in temperature. See students, when the clock is made, just like when scale was made, marking was done at one particular temperature, that is called calibration temperature. Similarly, when clocks are made, when it shows the correct 1 second, whatever temperature was that day, that is your calibration temperature. That calibration temperature they have not given. And just like delta T was what in that? T minus Tc. Similarly, delta theta is what here? Theta minus calibration temperature. This is what temperature? Calibration temperature. Or you can say the temperature at which the clock shows correct time. Now, which temperature will be more? Calibration temperature or the temperature at which we did this measurement? In the first one, calibration, because it is moving faster means what? The pendulum has become short, which means temperature is less than the correct temperature. So I must write correct temperature first minus which one? This is modulus, no? So I have to write bigger one first. So correct temperature minus 15 degree into 86400. Then in case 2, this is 30 degree and it runs slower by 10 seconds. Matlab you are losing 10 seconds. Matlab in a day you should have 24 hours. At 30 degree what happens? It is 23 hours 59 minutes 50 seconds. So 10 seconds you lost because it is moving slower. Here it is moving faster. So normal clocks will show in one day 24 hours past. This clock will show 24 hours past extra 5 seconds because it is moving fast. Understood? From the correct one. And that correct timing it was showing at what temperature? Theta C. Here for temperature we are using theta. So how will I write here in case 2? What is the time lost or gained in the second case? 10 seconds. Half alpha, alpha is constant. Which temperature will be more now? Calibration or the measured temperature? The temperature at which you are doing measurement. The temperature at which you are doing measurement, that will be more. So it will be 30 minus calibration temperature into 86400. Once you develop these two equations, now anybody can solve. Two unknowns, see. One unknown, one more unknown. Two equations. So two equations, two unknowns is easy to solve. What we should do first? Divide these two. Let us divide equation 2 by 1. Let's call this 2, let's call this 1. Why sir? Because this is 10, no, greater than 5. So 10 divided by 5, 2. Half alpha, cancel. Here 30 minus theta c, here theta c minus 15. Correct? 8640, 0 will cancel with this 86400. So this ratio will be left on the right side and here 10 by 5. Remember I am doing this by this, bigger number by smaller number. Now cross multiply. 2 theta c minus 30 is 30 minus theta c. Bring minus theta c this side. So 3 theta c will be equals to minus 30 will go there 60. So what was the temperature at which it shows correct reading or correct time? How much? 20 degree Celsius. Our aim is to find alpha. What we should do now? Substitute it back in any equation. Let us put it in equation 1. So equation 1 will give 5 is equals to half alpha. Theta c is 20 minus 15 into 86400. So this will be cross multiply. 10 equals to alpha into 5 into 86400. So alpha will be, this will be 5 2s are 10, this will be 2 4s are 2 3s are 6, 2 2s are 4. So alpha will be 1 by 43200. Unit will be per degree Celsius. Thermal stress. For stress, we used to write sigma, if you remember. For thermal stress, let's write sigma T. So what is this thermal stress? Let us try to. What was stress? If stress everywhere is same, what was the formula? T by A. Tension everywhere divided by area of cross section. Otherwise, at a point we have to define. I used to tell yes or no. So, what is this thermal stress? Look carefully, all of you. Imagine here this rod is there. No forces are applied anywhere. No tensile forces, no compressive force. Then tension everywhere will be what? 0. Now at this length, let me just gently keep here two walls. Gently matlab without, this rod is not trying to push the wall, remember. Wall is not trying to push the rod is not trying to push the wall. So right now you can imagine tension is 0. And that temperature, let us assume T degrees Celsius. So at T degrees Celsius, this rod is here and the original length is L. Area of cross section is A. This area of cross section is A. Understood? Now let us increase the temperature to T plus delta T degrees Celsius. What is the change in temperature? Delta T. Now what will happen? Rod will try to expand. But wall will say, bro, I am wall. I am wall. Stay there only. So what will happen now? Because rod wants to expand, it will push the wall. So wall will push it back. So the rod will be now under compressive stress, which was due to increase in temperature. That stress developed is called thermal stress. How to calculate that? Let us see. Now if walls were not there, what will be the increase in the length? L plus delta L. So what would be delta L? This is due to thermal expansion. So due to thermal expansion, what will be the delta L? Alpha L delta T. So due to increase in temperature, this would have expanded by delta L. It would have expanded by delta L if walls were not there. But walls is there or not there? So this expansion happened or did not happen? Did not happen. Why? Because the walls will keep the length same. How the walls will keep the length same? By pushing it this way. And since forces are same, because it is in equilibrium, the whole rod, tension everywhere will be same. So these forces, what they have to do? Whatever delta L was supposed to happen, that they have to make it 0 by compressing the rod or further expanding. Compressing. That compression is due to force, and due to mechanical force, the change in length that you create. Students, this is change in length due to temperature. So we have this formula. But in our previous chapters, we studied in solids chapter that forces can also increase the length or decrease the length. That increase or decrease in length, delta L, is found from where? Young's modulus formula, not this formula. So there, what was delta L, if you remember? FL by YA, I think. Those who forgot, you can start with Young's modulus formula, stress by strain. Stress was what? F by A, if everywhere force is same. This is stress. Strain is what? Delta L by L. So what will be delta L? FL by YA. Now this change in length is compression or expansion? Compression. Now because these walls are fixed, what should be the total change in length? Net change in length should be how much for the rod? 0. And according to formula, this much expansion should have happened, this much compression should have happened. So what is the total expansion? Alpha L delta T minus FL by YA. This much expansion should occur due to increase in temperature, and this much compression should occur due to compressive forces. But neither expansion happened nor compression happened. That means the total of these two. Why minus? Because one is expanding, one is compressing. So I have to subtract to find total change. So the total change in the length should be what? 0, because the length neither increased nor decreased. The point I am trying to say is, if this is your height, suppose somebody increased your height by 2 meter, and then somebody decreased your height by 1 meter, decreased your height, compressed. What will be your new height? This one plus 1 meter, or 2 plus 1? 2 minus 1, which is 1 meter. So you have to subtract the expansion with the compression to get the total expansion. But here there was no total expansion because it was between two fixed walls. So from here what will you get, guys? Acha, this F is by the way tension everywhere, okay? But T I don't want to write because T I am using for temperature. So now tell me what will be stress from there. So alpha L delta T will be FL by YA. What gets cancelled? L. So what will be F? Alpha YA delta T. But our aim was to find the stress. What is stress? Tension force per unit area. So what will be that? Alpha Y delta T or delta theta. So if you know alpha and Y, multiply. See, this is coming from temperature concept. This is coming from elasticity concept. And here all these are happening due to what? Change in temperature. Let's do one problem based on this. See question number 160. A steel rod of length 6 meter. Length of the rod is 6 meter. Diameter of the rod is 20 millimeter. Is fixed between two rigid supports. So this rod is fixed between two rigid supports. They want you to find stress in the rod. Stress in the rod when the temperature increases by 80 degrees Celsius. Young's modulus is given 2 into 10 power 6 kg per centimeter square. Now I know the unit of Young's modulus is Newton per centimeter square, but here they have given in kg per centimeter square. That means stress will also the answer will come in what? Kg per centimeter square. And alpha is given 12 into 10 power minus 6 per degree Celsius. There are two cases. In the first case, the ends do not yield. The ends do not yield. Now when I was teaching you elasticity chapter, I told you the meaning of yield. Yield matlab to give up. So if you stand on a hard floor and it doesn't depress, then we say it does not yield. And if it gets depressed, let's say soft mud is there or soil, then it will slightly get depressed, then we say it yields. So first option is the walls do not yield. Are you listening? The walls do not yield. If walls do not yield, what is the net change in length? Net change in length should be 0. That means thermal expansion should kill the compression due to walls force. What was thermal expansion? Alpha L delta T. What was the compression? FL by YA, yes or no? These two should balance each other in a way. The expansion and compression should balance. So L gets cancelled. I'm just calculating again. Already we did before. So what will be F by A? Alpha Y delta T. Those who remember the formula directly you substitute. What is alpha? 12 into 10 power minus 6. What is Young's modulus? 2 into 10 power 6. Now students, actually this kg should be converted to Newton. This is actually kg weight they should say. Only kg they can't put. Because it is force by area, no, not mass by area. So kg weight they should write. Kg weight matlab you have to multiply with g to make it Newton. But here options are also, answer is also they want in kg weight. So we will keep it as kg weight. No need to multiply with g. Into what is the change in temperature? 80. Now you know that alpha is 1 by degree Celsius. This is Celsius. Celsius cancel. So stress will have same unit as Young's modulus. So whatever was Young's modulus unit, answer is also in same unit if you look at the question. How much this will come? 2 2s are 4, 24 into 8. 8 4s are 32, 8 2s are 16, 19. So 192 into 10 to the power, these two will cancel. Minus 6 plus 6. So 192, 0. This 0 is there, no? That much stress matlab kg per centimeter square. But I want to write kg weight ma. It looks very awkward to write only kg. So second case is ants yield how much? By 1 millimeter. Matlab 1 millimeter expansion is allowed. That means now you cannot say these two balance. So what was the net expansion formula I told? That's why I taught that way. So what was the net expansion? The expansion due to temperature was alpha L delta T. The compression due to force was FL by YA. Since this is expansion, this is compression, total expansion I should put minus or plus? Minus. And this is given 1 millimeter. Are you clear, students? So this is the expansion which is allowed. So bring FL by YA this side. How much it will be? Alpha L delta T minus delta L net. So what will be F by A? Alpha L delta T divided by multiply with Y divide by L minus delta L net multiply with what I told? Y divide by what I told? L. Correct? Now this part to be already calculated. 1920. This part I need to calculate. How much is delta L? How much expansion is allowed? Total 1 millimeter. 1 millimeter will be how much? 10 power minus 3 meter into Young's modulus is given how much? 2 into 10 power 6. What unit they used? Kg per centimeter square. So be careful guys. This Y is in what unit? Kg per centimeter square. Sir, if this is per centimeter square, why did you make it meter? Because this L is in meter. Kg per centimeter square. This L is given, what is the original length? 6 meter. So did you see why this I converted to meter? So that meter cancel and the unit of this whole thing will be still kg per centimeter square. So this will be 1 by 3 into 1000, no? Yes or no guys? 1920 minus, what is 1000 by 3? 333.3333. So let's just write 333 approximately 1587. So how much this came guys? 1587. Unit is because kg per centimeter square was given Young's modulus, it will stay kg per centimeter square. Nice problem.